Hello everyone, in this tutorial we will create the multi-lane road that we have the material that can adjust the number of lane. We will create the switching lane system at the intersection when the vehicle turn left or turn right. And first we need to improve the yielding system. In our last update, we have the problem because when this vehicle do the grid race, it's overlap with this capsule collision of this vehicle and set this as the obstacle. So we need to ignore this. We set the obstacle only for this vehicle location and this static mesh. Open traffic tutorial.sln. Go to vehicle AI component base.h. On capsule component function, we set the capsule set collision object type ECC vehicle and set this collision response to channel ECC vehicle. Go to speed trace along spline path. And this speed tracing goal, we need to add visibility and vehicle type. So before this for loop, static cons p array p enum as y a object type query object types array wall new engine types convert to object type collision and all visibility new engine type convert to object type collision channel vehicle. And this speed trace we change to speed tracing goal for objects. And this is object type array. Save this. Next we go to vehicle yielding system.h and .cpp. Vehicle yielding system, we copy this variable. Next intersection action to has next intersection. Copy and we delete this. Go to vehicle AI component base, and we paste it here under yielding system. We move it here because we want to use this variable in other system like switching lane system for the intersection. And save this. Go to vehicle yielding system, and we have the error because we move this variable. So we need to add owner vehicle to this variable. And this one we add owner vehicle distance to next intersection. And this we don't need yielding system. Delete yielding system. And we save this. We call yielding system. We need another function. Bool evaluate yielding at intersection. Use Spline component. Spline component. Float sample distance. A road actor. Road network. And we copy this function. This is yielding system. If it's not valid, road network is not valid, return false. Float intersection distance for spline component. Get distance along spline at location. Yielding intersection. Spline coordinate space. World. Float. Yielding distance equal intersection distance. We adjust distance based on action. On the action. This function we have error because we need to include road actor. Include road actor.h. So now we don't have the error, which owner vehicle next intersection action. Case 1. This next intersection action. If the value is 1, it means we turn right in the next intersection. So we brake. This function we want to calculate the yielding location at the intersection of the vehicle. Case -1. It means we turn left. Yielding distance. We get the yielding distance, road network, road width, divide it by 2. Then brake. And if it is 0, go straight. Yielding distance. We get the road width divide by 2.5 and brake. And if it is default, we just return false. We exit. And for the result, we return sample distance vector equal yielding distance. The tool we call AI component base. Spear trace along line path. And this is where we break. We always use the intersection distance subtract with this road width divided by 1.5. But sometimes the vehicle is too far from the intersection. It is depend on the turning action of the vehicle. So when it's turned right, the path should be shorter than turn left. So we use this evaluate yielding at intersection function to divide this case into 3 cases: turn right, turn left, and straight. You can delete this. Yielding check. If yielding system and yielding system should yield if yielding system evaluate yielding at intersection line component sample distance road network and break. This vehicle yielding system, we can draw debug. Draw debug sphere. Get world. We get spline component. Get location. Add distance along spline. Yielding distance is spline coordinate space world 250 12 color red ball row and the thickness is row. Let's run this. We play this. And we can say this is the yielding location. We adapt the yielding location depend on the turning action. Go to speed trace along spline path function and this break. Stop checking if the overlap vehicle is not the same as ours. If overlap vehicle or overlap vehicle, overlap actor not equal vehicle actor, we break. Go to yielding system and go to sort vehicle, yielding vehicle. This sort we use yielding vehicle variable, so we need to use this input instead. Vehicle array. And we need to clean this function by create another function. Name is assign crossing vehicle. U vehicle AI component base crossing vehicle. U vehicle AI component base yielding vehicle. Okay, this. We can write this in crossing vehicle and in yielding vehicle input. If not in crossing vehicle or not in yielding vehicle, return. First we update the yielding vehicle status in yielding vehicle yielding system. We set it to should yield true. In yielding vehicle yielding system yielding intersection wall in yielding vehicle. Next intersection in yielding vehicle yielding system crossing vehicle equal in crossing vehicle Next, we update crossing vehicle status. In crossing vehicle, yielding system, yielding vehicles array, add unique in yielding vehicle in crossing vehicle. We set yielding intersection location. Wall in crossing vehicle next intersection. And another is vehicle yielding system crossing vehicle equal in crossing vehicle. And save. Next, we update this function resolve vehicle yielding status. And delete all of this. Load distance threshold equal owner vehicle road network road width divided by 2. And if fmat abs our distance to intersection subtract with the distance to intersection less than distance threshold and our distance to intersection greater than distance threshold and the distance to intersection greater than distance threshold. If it's true, we sort the vehicle overlap vehicle here new vehicle AI component base pointer vehicles to sort wall. We only have 2 vehicles, our vehicle and overlap vehicle. and we sort yielding vehicles to sort. And we assign crossing vehicle. The first vehicle in the array have the priority vehicle to sort the row. And the second vehicle in the array is yielding. And else if our distance to intersection less than the distance to intersection, we assign crossing vehicle. Owner vehicle, overlap vehicle. And the other one assign crossing vehicle, overlap vehicle with owner vehicle. So we have two options. The first, if we have enough distance, we use right of way to assign crossing vehicle. And if we don't have enough distance, we make decision based on purely the distance to intersection. Or owner vehicle road network is not valid, we return. And we run this. So now we already improve our yielding system. And stop this. You call AI component. Can perform term maneuver. Get yielding system should yield at a branch when it falls. And save. Close this. And we can delete this draw debug sphere. So we call yielding system.cpp. Update speed setting. We Get spline component. Use spline component. Spline component for owner vehicle spline actor get owner vehicle spline actor find component by class. Use spline component. And pointer. And this we add another condition is vehicle align with spline component 30. Now calculate dynamic deceleration distance. We want the vehicle to move faster, so we decrease the reaction time and deceleration rate. Average is 450. Run this. Vehicle AI component. Now we need to improve the tracing for road actor. And tracing for road actor, this function. Instead, we use sphere tracing. Multi-sphere trace for object. And this is hit. Start at type. Radius, we get grid gap. To float. Multiply by 4. Need to radius. So we going to create new map for testing. Let's add a new level. City sample vehicle traffic 2. And we can go to project setting, go to map, and use this with 2. Open this level. It is black, so we need to add the lighting. Go to environment light mixer. We can add skyline, atmosphere, fog. This is optional. Volumetric cloud. And we can go to the last project. copy this floor and paste it in this new map and go to world setting, add game mode is we call game mode. If we move this floor upward, and for this location is 6,000. And we create this road network on this floor. Next, click create, add a vehicle set, and we play and we set target. You can see that this vehicle cannot get this road actor. So this vehicle always avoid this road actor. We can go to vehicle AI or AI component. Open graph. To use road actor. And we can enable this draw debug for duration. Like when we set this target, we can see this tracing is down here. So it didn't detect this road actor. To solve it, we need to go to vehicle AI component. And we have this local variable. Add a few variable. We use only landscape to get the boundary. So we need to use all the floor actor to get the boundary tracing. Change this name to actor bound height, origin height, and this to float. Max height, min height, current min height, current max height. And we delete this. From this sequence, first we get all actor of class with text, and we get the text is floor, get actor. For each loop of this actor, we want to get the min and max boundary height of this floor actor. First is valid. get actor bound. This origin, we break this origin. Box extend, break. Current min high and current max high. Use this z subtract with this z of the boundary. This is min and add for max. This array index, if it equals 0, it means it is the first floor actor. So we don't have the previous value to compare. We set it to min high and max high. If it's true. Current min high, current max high. But when it's false, we need to compare it first. When current min high, if it's less than this min high value from the previous actor, if it's true, we set min high with this current min high. If it false, we ignore it. The same with max high. Get current max high and check if greater than this max high value. Create a branch and we set max high. And it's true. When we complete the loop, we need to set origin high, max high, and min high, add together, divide by 2. Get max high and min high, subtract this, absolute, float, and divide by 2, add with 100. Then we set actor bound high. And next, we do the tracing, box trace for object, and origin high, this origin high, this is actor bound high. And it is correct. Let's play again. When we set this location, we get this floor boundary and we calculate the mins and max. and we trace it depend on this floor location and floor boundary. Error prevention, we go to event graph function and this line trace for surface, and we rename this to line trace for surface, and we can collapse this. Collapse as a function, name it line trace for surface. And we connect this. Close it. And this is location. And this return value. And next, we copy this. This is right location. And delete. And go to event graph. Go to target location. So we disconnect this and move it down a little bit. We create function line trace for surface. Line trace for surface. And we get actor location. Get recall actor. Get actor location. We only go to target when we overlap with the surface. And when it falls, we ignore it. Then create a sequence. And connect this. Create the network path. And compile save. And it is still working. We can disable the route. Use line trace for route actor. We should use route actor. We can set this draw debug to none. And we can close the project. Next, we're going to create multi-lane for our road network tool. This road network tool editor. We go to road network tool, line tool. Line tool.h. This width we need to divide it into lane width. So the claim value min is 300, max claim max is 400. And this variable is lane width. Equal to the for value is 350. And another variable is lanes per direction. So we have two directions this road, 1 to 3. So we limit this to 3 lanes. In 32 lanes per direction equal to 1 for the default value. And we need to set this to config. This tag is lane width, and this is lane width. And the other as this get in, because this is integer. Lanes per direction. Lanes per direction. Set in. This lane per direction and lane per direction. Save it. And we need to set the variable to road actor. Road actor.h. We have road width. We need this. And we can copy this view property. Road property float lane width. And in 32 lane per direction. Go to road network tool, line tool. This property width, we don't have it anymore. So we set lane width instead. For Spline actor lane width properties lanes per direction equal Spline actor lanes per direction. We fix this error property width. We need to calculate the total width of the road by using the lane width multiply with lanes per direction and multiply with 2, because we have 2 directions. Properties lane width multiply with properties length direction type with 2.0 and copy this. Paste here and here and point on same spline function. And the last is this debug width. So we need to calculate the total width. Next, we need to display the property on our road network tool. Line tool customization. And this lane width property. This is length per direction property. We need to add it to this detail builder lane width property. And this is lane width. This category is lane width property. Length per direction property. For detail builder, get property and copy this. This is length per direction property. Category, add property, length per direction property. Sorry, this is length per direction, add property. And we need to set it when we generate the road mesh. When we click the button, this fall load lane width in length per direction in lane width property, get value lane width length per direction property, get value length per direction. Road actor lane width equal to lane width road actor length per direction equal to length per direction. Save this and run. Go to road network tool. Now we have this lane width and this lane per direction. If we change this lane per direction, we have 2 lanes for each direction, so in total we have 4 lanes. And we can change this lane width. So I set it to 350 for default value. We change it to 3 lanes for each direction and create. Next, we will create the material to show this lane, and we can set this material using this lane per direction, and it generates the lane divide pattern. We create road material, name it M lane map. Add another material function, MF multi-lines. Open this material function. Get height coordinate function input lane mark thickness, and this is scalar input because we want a float input. Copy this, name it to lanes per direction. Multiply by 2. And then we claim this. Min 1 subtract width. And this is max. Multiply by 2. Multiply with this value. Add 0.25. Sign this lane mark thickness. We reroute node. Multiply with -1. And another one, we reroute. Subtract with 0.5. 5 subtract with this value. This sign multiply with this and add. Next we subtract. Round. Clamp. Min 0 and make is 1. And then mass. No component mass. Or we only use or channel connect to output. And then we call function call multi-lines, ms multi-line. And convert to parameter. This is length per direction. Press 1 and then left click and convert this to length max thickness. This is 2 and the thickness is 0.01. And length per direction, and this is thickness. We can set to this plane view. But now we have the vertical line. We use mass or instead we use G. So we will get this horizontal line. And this length per direction, we can set the number. If we set to 3, we get this 3 lane and another 3 lane. In total is 6 lane. If we set to 4, we get 8 lane. And this is the thickness of the lane. You can adjust it according to your road size. 0.05 is thicker. Create another material function. This name is mf dash pattern. We want the dash pattern for this lane. Create text coordinate, multiply, function input, scalar, and dash scale. Need to this multiply. And then component mass or sign, add, we can copy this, the scale, and change this name to the space. Sort priority, we can set it to 10, so it stay after this the scale. Round, one subtract with this value, and clamp, throw to 1. We get the same pattern because we have this sign function. Function called dash pattern and the scale 2 and the space 0. We can connect to base color. We see this is the 0 value and this is 1. So we can loop with this multi-line. Linear interpolate, start with this and set this to 0. And we get this dash pattern. Next, we want this center line to be, we want to have only one center line. So MF multi-line, duplicate this, name this to MF center line. This multiply multiply 1 with 2 and connect to this. Next, this length per direction, power 2, and this landmark thickness we divide with this length per direction and connect to this. Go to M landmark, function called MF center line, copy this length per direction and length thickness, and we can connect to this base color. When we set to any value, it will scale the thickness of the line the same as this multi-line's thickness, but it have only the center line. Next we do linear interpolate. And 1 is value alpha and like this. So the center line will be straight. And we will download the material, the road material, alpha material from web marketplace. Search for alpha, and you can use any material that you like. Choose this material, add to project. Choose the quality, high quality, and add to project. Let's copy this material, this color, and normal. Go to road network material texture and paste it here. Go to M landmark. Export. Multiply with 2 or with 3. Depend on the scale of the pattern of the alpha. Drag this color. And normal. They multiply 0.8. And then this one, this love be multiplied with 0.9 to make it a little bit transparent. And connect to alpha, to base color. And we can see this material. Normal is 1 to this. And then this is alpha. And connect to normal. The roughness, we can set it to the value 0.8. And at the center, I want to have yellow line. This linear interpolate. Add a color. Choose yellow color. And use this center line. So the center line will be yellow. And I want when there are only one lane per direction, I want this line to have dash space, to have dash pattern. Or if lane per direction 1, the center line, and connect this. And connect with this alpha. Command on this. Use only dash lines when lanes per direction equal 1. And we disconnect this. Now if we set to 2, we have this straight line in the center, 3, 4, 8. So you can set it to any number of lanes. And set to 1. Apply. Next we create another material. M road black. This material we will use it in the intersection area. Can go to this and copy. Multiply with 0.8. And this is base color and normal. And the roughness 0.8. Save all. Next, we need to apply this material to the road network. Open traffic tutorial.sln. Close all of this. Go to road mesh generator.h and .cpp. Road mesh generator.h. We set road mesh material and collision. We add input variable a road actor boolean is intersection. Can go to definition and add this input. this material. Change this name mi landmark mi landmark new material interface, select material equal load object, new material interface, now pointer x and the location of the material. His name is m road black dot m road black. And this section index if is intersection of mesh component set material. If it is intersection, we only set one material, the alpha material, like material. And L, we have two material section. So the first section index equal to 0. Rock mesh component set material. Section index material. Rock mesh component set scalar parameter value on materials. X length per direction. Road actor length per direction. And else rock mesh component set material. Section index select material. So this we need to set the length per direction for the material. So we have the right number of lane on the material that we generate the road mesh. Next, we need to set road mesh material and collision. This is road actor true, and this one is road actor false. Road actor true, road actor false. Save, and we run this, and we create material instance. Mi landmark. Save. Go to road network tool and click create. Now we have this road material. And can change this to 2 lane and 1 lane, and it's working correctly. Set back to 3. Create more road network. Create, and we can save this. Next, we need our function. Event graph. This find path road network, we want to have the lane setting so we can offset to the correct lane. Close. Go to road actor.h and .cpp. Find path road network with lane. In current lane. The same with this. Refine path with line points with current lane. and offset line point in current lane. Go to road network. Find path road network with lanes. And this in current lane. And this and note we copy, delete it, add it under this adjust spline node, at node location, adjust path, road width with current lane. And define path with spline points in current lane. This offset beneath current lane. To offset spline points in current lane. This offset width we need to set it depend on the lane. Lane width divided by 2. Add width lanes per direction. Subtract width current lane. And multiply with lane width. And we copy this. Its previous array with the tail. And we can run it. Go to vehicle AI component. And create a network at this function we call drag from road network. Find path network with lanes. And reconnect this path at node or actor, start location, target location, right offset, add to target, forward path, this, and current lane, we set it to 1. Let's play. If we set this target, this is the first lane, the second, and this is the third. So if we choose the scan, you can see this vehicle use the center lane. And if we set it to third, this vehicle use this third lane. Go to spline point utility.h and spline point utility.cpp. We need another function. This function is static void find closest segment. So you can download this project file, link in the description below. We have this function. Paste it. Find line point utility. You can copy this. This function, the input is array of the path node of the intersection, and we find the closest point and find the closest segment. Go to vehicle AI component base.h and .cpp. We include line point utility. To yielding system A and CPP. This get next intersection info. We will move it to vehicle AI component base, and we also make some change to this algorithm. Can delete this. Save. Scroll down. Bool. Get next intersection info. We call AI component. You can download this project file. We call AI component. Find this function. Get next intersection info. Copy. Paste it down here. This nearest intersection we need this. Go to vehicle AI component base.h and copy this. Add vector nearest intersection and save. Before we use the spline path directly to get turning action for the next intersection to turn left, turn right, or go straight. But now we use this path node instead because it is more stable. The result didn't change according to the lane offset. This path node location we get from road actor when we call this find path road network with lanes function, and we return this path node locations. Go to vehicle yielding system, and now we need to delete this function. Get next intersection info, and this change to owner vehicle and save. You can download this project file. Link is in the description below. Lane switching system.h. Copy it. Go to source, vehicle AI, and paste it to public. And then to private. We delete .vs, binary, intermediate, save, and we generate Visual Studio project file again to include this lane switching system. So we open lane switching system.an.cpp. We have a function to determine lane for intersection. So we do the switching lane when our vehicle is near the distance to the intersection. And if we turn left, we need to go to the leftmost lane. If we turn right, go to the rightmost lane. If we go straight, we get the middle lane. And after we pass the intersection, we get back to the center lane again. We call AI component base, and we add another class is U lane switching system. Add variable U property. Category is lane switching. U lane switching system. Pointer lane switching system. U property in current lane equal 1. One is the rightmost lane. We call AI component.cpp. We need to include lane switching system.h, and this we create new object. Lane switching system equal new object. New lane switching system. This new lane switching system static class. Copy this lane switching that owner vehicle equal this. And so we run the project. Auto vehicle AI component. Event graph. Before we set vehicle speed, create a sequence. We get yielding system, get should yield. We switch when it is false. Get lane switching system. Determine lane for intersection, and it is false. Get a road network. Get a branch. If it's true, we update target location. Get spline actor. Not equal to default spline. Create a branch. If it's true, we reset pathfinding. Duration 0.5. So when we switch lane, we need to update target location. And when we update target location, we create new road network path. And we get current lane set to this current lane. We find our vehicle. I made a mistake when I create find road network path function. Go to road actor.cpp. find path road network with lanes. And this, we need to use this copy path nodes instead of path nodes. And then we run the project. We play this and set the target location to here. And when it's near this turn, the vehicle will change to this left lane. And then it switch back to the center lane. And for this turn right, the vehicle will switch to the first lane. And it's working correctly. But we need to prevent the swerving behavior of the vehicle. Under this, adjust target speed with tempo alignment. We create another function. We can copy it from vehicle AI component base .h that we download. Adjust target speed based on spline distance. And another function, adjust target speed based on spline distance. We copy. Line trace obstacle forward. So we slow down the vehicle speed when it is far away from the spline. We need to run this. Go to vehicle AI component. Calculate target speed. Calculate target speed based on curvature. After we adjust target speed with tempo alignment, we adjust target speed based on spline distance. And this is base speed. Distance threshold is grid gap. To float, make slowdown factor 0.7. And this alignment threshold 15. We increase it and 0.7 for alignment weight. And we play. That is target. This target instead. So now the vehicle will slow down. so we don't have much swerving behavior of the vehicle. Next, add traffic. BP traffic manager, and we can add vehicle class. Delete this BP vehicle 6 traffic manager vehicle class. Add multiple vehicle. Vehicle 3, vehicle 4, vehicle 5, vehicle 6, vehicle 7, vehicle 12, and vehicle 13. And we can set this number of vehicle to 30. Now when we play, we will spawn the traffic system on this road network. And all these vehicles will switching lane depend on the intersection turning. Next, we need to optimize this project. Go to vehicle AI component base. This capture collision along spline path, yielding we delete this distance vehicle to spline. So next we need to replace the spline road. Copy this spline road.h, plug in vehicle AI, source vehicle AI, public, paste it, replace file. The same with this spline road.cpp, copy and replace this file. Next, we generate Visual Studio project file again. And then open this traffic tutorial.sln. We open spline road.h and spline road.cpp. This spline road in this function add spline mesh component. I use multi-thread for register the mesh component using game thread. And this calculates spline mesh property. We use parallel force to calculate this value for the spline mesh component before we set the property of this spline mesh component. And I change this function from vertical line trace for normal to vertical line trace for surface. So we can get hit location and hit normal at the same time. We can open this vehicle AI component base that we download it. Copy this function, project path points to terrain. This function is under calculate average slope. And the definition of this function project path points to terrain. Close this. Under this function, we paste it. This we just do the loop for the path points and do the line trace for surface fallback, and then add to the array that is the result projected path. We can run this. Go to vehicle AI component, one graph, create road network, and this project path to terrain. We change this. Project path points to terrain. And this is array input. And set this path to final target, path complete. Compile. Terrain handle, we delete this project path to terrain function. We need to find this first. Copy. And this location, we change this function. This is adjust point. Get adjust point to this project path to terrain. And delete project path to terrain. Delete this line trace for location fallback and vertical line trace. Next, we go to traffic nature. In this event, arrive at destination. We get random target location on road. We need to check if this location is near our vehicle. So if it is near, we do another get random target location. Get actor location, distance with this greater or equal road actor, road width to this. We can multiply it by 5, create a branch. If it's true, good. If it false, we do another random and copy this. This is the target and set location. Location on road. We need to multiply this by 2. This is min, and the make the same, we multiply it by 2. Subtract with this spline length and compile and save. Next, go to vehicle AI component and move this line trace for surface function to the correct category is line trace category. Save. Peer trace along spline path. Go to definition and we will optimize this a little bit. We can go to vehicle AI component base .cpp, copy this peer trace along spline path and paste it here. Next, we go to capture collision along spline path. And we can delete this distance vehicle to spline because we stop using it. Before we use it in this if and return. Save. And run this project. So now we have this lane switching system with we update target location when we switch the lane. And this road network, we can change the material. We can set how many lanes that we have from 1 to 3. And we can change this lane width if we want to. And play. And now our vehicle can handle multi-lane. But in this project, all the roads have the same number of lanes. In the next tutorial, we will create different lanes for each road. Thank you very much for watching. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next tutorial.